and share my screen and move on from there. So there's your chart again. Everybody got it? You okay? I hope. All right. Relationships between categorical variables. Now we're talking about conditional distribution. So we went from marginal conditional, okay? The two-way table contains much more information than the two marginal distributions of opinion alone and gender alone. Okay. It's a big, long definition. Trying to get everything moved away.
I don't understand it when you're filling the blanks, but as soon as you start like drawing stuff out, then I get it.
Right, and that's why I do it. But then you can go back and read it later.
Yeah.
So like it's a big
Like when you're filling in the blanks, I'm like, oh my goodness. But then as soon as you start doing it, I know what I'm doing.
Haley, that's called teaching.
Yeah. Because then I know how to do it, and I ain't confused no more.
All right, marginal distributions tell us nothing about the relationship between the two variables. Okay. So what this is saying is we only saw the relationship between the superpowers. So we saw how flying compared to freezing or compared to invisibility. But what we didn't see was how flying compared in US versus UK. So we didn't use those things. So like here, we're going back to this gender, chance of getting rich. And now we're going to talk about the male and female part of it, comparing that to the gender or the gender to the opinion. Like what is the comparison of male versus female who think almost no chance or something like that. Okay, so that's what we're looking at now. So to describe a relationship between two categorical variables, we must calculate some well-chosen percents from the counts given in the body of this table. All right, so this is the same table we just looked at. There's nothing any different. We're going to get I think the superhero is going to come back in just a minute. Maybe tomorrow. Yeah, tomorrow it'll come back in. So all we're going to do is look, let me see, hold on. Okay. What we're going to do is see how they compare to each other. So we can study the opinions of women alone by looking at only the female column in the two-way table to find the percent of young women who think they are almost certain to be rich by age 30. Divide the count of such women by the total number of women. Okay. So if we look at this is what we're looking at. The percent of young women who think they are almost certain. So we need to underline that. That's going to tell you exactly what to put on top and what to put on bottom. Okay, what to put on top, what to put on bottom. So this one, to find this, you're going to do women who are almost certain divided by the total women.
Could there be a time where a question asks us about like the women related to the entire table?
Uh-huh.
Okay.
Uh-huh. So to find that would have went with the marginal because you're looking at the total table. So we did the marginal of almost no chance, but you can flip that around and do the marginal of female over total or male over total. So what are the percent of female in the thing and what are the percent of male? So we just did the rows, but you can do the columns too. And this is why I'm underlining the sentences because it'll tell you exactly what to do. So this is going to be your total. What you're looking at is total young women. And then this almost certain is the part of those totals. So when I teach Math 1, Math 2, Math 3, and we're doing ratios, it's always part over whole. So what is the part that we're looking at? We're looking at the part that is almost certain over the whole total women. So I don't know if that helps you look at it a little different, but that's exactly how you're going to do it. So then, what is your total of women who are almost certain?
486.
486. So that comes right here, women almost certain, 486. And then what's your total women?
2,367.
And then that gives you a percent or a decimal of 0.205, which is a percent of 20.5. So doing this for all 5 entries in the female column gives the conditional opinion. Or sorry, the conditional distribution. I'll move it over if you can't see it. Conditional distribution of opinion among women. So we're going to do that now. So we are going to do almost chance, some chance, 50-50 chance, a good chance, or almost certain. So we did the almost certain. So I'm going to drop down to the bottom and put this one in. This is the one that we just did. So then now we need to do almost no chance. So you need to look for women almost no over a woman total. So what was the woman that were almost no? What was that number? Or female almost no?
96.
96. And because we already have done it once, what was the woman or the female total? Two, three, six, seven. Is everybody good with that? This is 4.1%. Some chance. Some chance. So if we go back up to the table, we have some chance. Female is 426. The total is 2367. So 426, 2367 gives you a percentage of 18. 696, 2367, 29.4. If you get lost, tell me. I'm just writing them down to save you some time. And then a good chance was 663 females out of 2367, which gives you 28.0%. So everybody good? All right. This is the last page, and then we have to do like one little fill in the blank at the top of the other one, okay? So conditional distribution, again, here's your other one. So marginal distribution versus conditional. You need to know the difference, marginal versus conditional. This describes the values of the variable among individuals who have a specific value of another variable. So the next example, it just wants you to do men. So you did all the females. So we're going to do the males. And I'm going to go ahead and tell you those, but you find them the same way. So the males that are almost no chance over the total males. That's a no, sorry. So male almost no was 98 in the chart, and the total males were 2459. That gave you also a 4.0 percentage. Okay. Some chance, 286 out of 2459, which gives you 11.6%. And everybody's okay with where these numbers are coming from. I don't want you to be lost just because I'm writing a bunch of stuff down. 50-50 was 720 males out of 50-50, and the total males were 2459, which gives you a 29.3% chance. A good chance, 758 out of 2459, which gives you 30.8%. And then almost certain is 597 out of 2459, which is 24.3%. All right. So again, this is the distribution among of opinion among young men. So in a second, you're going to see what I mean by that. That sentence will give you what you need to know. So I kind of told you on the other one, and I'm going to kind of ask you about this next one. Okay. So there are two sets of conditional distributions for any two-way table. One for the column variable and one for the row variable. So far, we've looked at the conditional distributions of opinions for the two genders. We should also, or we could also examine the 5 conditional distributions of gender, one for each of the 5 opinions, by looking separately at the rows. That's what we're going to look at in just a second. For instance, the conditional distribution of gender among those who represented almost certain. So here's what it says. Gender among those who responded almost certain. So we had 2 genders. We had female and we had male. So we're going to do 2 different percentages. We can't do them together. We can't do male and female together. And then you need to figure out which one is what's your total, and then what's your part. So what are we looking at? You can tell me either one. Which one's your part, which one's your total, but you need to identify it when you talk to me. What do you think? Come on, guys. Worst case is you'll be wrong. It's not a big deal. Everybody feels like you do right now. Not real sure. What do you think? Remember when we...
Total be almost certain?
Yes. Remember when we had this? Where did I mark it at? I gotta find where I underlined it. Okay. So the percent of young women was your total, who think they're almost certain was the part. On this one, the gender among those who responded almost certain. So we're splitting the gender, but we're only looking at the almost certain. So we're looking at the almost certain as our total. That is what we're splitting into gender. So this would be our total. Okay. So we're going to total that out. And this is what you're going to have on the bottom is your total of almost certain. This is where it gets crazy. You got to be careful. But what are we looking at on the top? Are we looking at all the females?
Just the almost certain females.
Just the almost certain females. So female and almost certain. That's what we're looking at as our part. Okay. So if we go back to that, the females that were almost certain were 486 of them. And then the total for almost certain was 1083. We don't care about the rest, so it's going to be a lower number than what we've been seeing, which gives you a 44.9%. We're going to do the same thing for male, except for this time it's going to be male and almost certain, while it's still the total that are almost certain. That would have gave you 597 over 1083. You're going to do some practice with some conditional distributions in your homework. Just be careful about it. Okay. If you have any questions, let me know. All right. That is, of the young adults who said they were almost certain to be rich by the age of 30, 44.9% were female. So that's what it's asking. How many females were almost certain? Okay. How many males were almost certain? And that's looking for that percentage. And then 55.1% were male. 2 more blanks to fill in and we'll be done. I'm sorry I kept it a little long today. Hopefully tomorrow won't be as bad. Okay. All right, so everybody got those? We're okay? 4 more paragraph. Because the variable gender has only 2 categories, comparing the 5 conditional distributions amounts to comparing the percents of women among young adults who hold each opinion. Figure 1.4, which is in your book, makes this comparison in a bar graph. I didn't want to put it on here, so you don't have the bar graph. But the bar heights do not add up to 100% because each bar represents a different group of people. Okay. And then again, that's where we're going to stop. And I am going to stop recording.